It's been a while, so it's good to have you back. And you can see in front of you this word logarithmic functions. Not sure if you're familiar with that term, but if you hear me just say logs, it's the same thing as the logarithmic functions. And these logarithmic functions find power values. So our x value is really looking for a power in today's lesson. We're going to learn how to rewrite exponential functions into logarithmic form and vice versa, because that's going to allow us to find the value. And we're also going to use our calculator in some instances, and sometimes we will not use our calculator. There are times when you simply cannot use your calculator, so we need to know how to rewrite. And then we'll talk a little bit about this common and natural logs, and it is something that you're going to want to get to know because our calculator does indeed handle the common and natural logs. So let's get started. Now, before we can move forward with logarithmic functions, we need to familiarize ourselves with some of the terminology. So get this down in your notes. B to the P equals N. Now, what do you think the B, the P, and the N represent? I'm going to help you out with that a little bit by having you look at this problem. 10 to the empty box means we want to fill in a value there, equals 1,000. What do you think is an exponent that belongs in that 10 to the what? I hope you're thinking to the third, because there are 3 zeros set off against that 10. We would need 10 to the third, and that would be an equation that would be true. And so now what do you think the B represents? I was pretty clever on how I worked this out for you. You're thinking base, aren't you? So that's pretty easy to remember. What about that P? You're right, the P is power. And the N would simply be the number that it's set off against. So there you go. There are some basics, very important. Make sure you have that down. B for base, P for power, N for number. Rewriting the expression in logarithmic form. Let's keep in mind something I talked about previously, and that is that logs find powers. Now, you're familiar with exponential form. We've been working with that, and I gave you a little hint as to how we're going to read that. The base to the power equals N. How are we going to write that in log form? We're always going to start with the word log. We're going to subscript the base and drop it a little bit below the level of the word log. And then we're going to have the number equal level with the word log equals P the power. So here's how we're going to write 5 squared equals 25. Let's start what we call a rewrite. So the base is 5. So the base of the log is 5. What does that mean? The base will be over here. Let's write the word log. That's the first thing we do. And now we're going to drop that base of the log just below the level of the word log. And we now read this as log base 5. What's going to come next? Well, we see that we need the number N. So the N is going to come next, and our N is 25. So I'm going to write 25 next to that word log, keeping that on the same level with the word log. The 5 is now a subscript, and we are going to equal the power. What's the power here? The power is 2, so I'm going to go ahead and write 2. And that is how we write a log form. Log base 5 of 25 equals 2. We can move the other 2 examples along a little bit more quickly now. We always start with the word log, so let's do that. There we have the word log. Now, what's our base? Our base is 4, so we're going to write this 4 just underneath the word log like that. And we're going to take this 1/16 and we're going to slide it over, and we'll slide it to the other side, and it equals our power, which is a -2. And that's our rewrite. Go ahead and see if you can do the last one without me. See if you can write that 10 to the -2 equals 0.01. Press the pause key, write it, come back and see if you got this. Okay, so are you thinking that I'm going to write the word log? And did you write 10? And 0.01 equals the power, which is -2. There we go. And that's how we go from exponential to log form. We don't always go from exponential form to log form, and we need to know how to reverse the process. There's nothing tricky about it. It's as simple as you would think. And in example 1, where we have the log base 5 of 125 equals 3, Simply take the base of the log, which is 5, and make it the base of your power. Your power is always set off against the log, so that would be the 3, and it equals the numerical value of 125. So there you have your BP equals 125. In the next example, log 9 of 3 equals 1/2. We're going to start with that base of the log, that's the 9. Looking across the equal sign, I see the power, and that's a 1/2, and it equals 3. And finally, log base 2 of 32 equals 5. We're going to make that base of 2 to the 5th equals 32. So there you have it, from log form to exponential form. Now we're going to look at some log expressions without using a calculator, and we're going to have to evaluate them, meaning we're going to have to find a value. We have a very crucial skill from Chapter 7 that I'm going to recap with you to make sure that you remember how to evaluate 32 to the 3/5. We want to take that 32 and break it down to the lowest base we can, and many of you have a chart that you use, or perhaps you know how to break it down prime factorization. Either way, you would get 2 to the 5th, and the power to that is 3/5. The 5's cancel. We're left with 2 to the 3rd, so the value of 32 to the 3/5 is 8. The important thing I want you to note is that we're going to bring it to a different base. So in example 1, log base 4 of 64, we want to try to start this problem, but we're a little confused what to do. We really need to change it out of log. We want to do a rewrite. And in order to do the rewrite, we have to use a star idea here, and that is this: set that expression to x. Once you remember to do that, this will look like something you can work with. So if I set it to x, can you do a rewrite? And I'm sure you can. We just went through it. I'll walk you through it again. I know you're just trying to get used to how to do a rewrite. And so here we go. The 4 is the base of the log. It becomes the base of the exponent. Logs solve for exponents, so therefore the x becomes the power of 4. We're going to equal that to the number it's set off to, which is 64. Now we're not done. We have to find the value for x. Remember, logs find values for exponents. Can I break that 64 down, just like I did that 32 in the prereq? Can I break the 64 down to a lower base? And how about if I try to get it to a base of 4? I think I can. I can break it down to 4 to the 3rd. Now that the bases are the same, what value do you think x is going to be? Well, it'd have to be, for this equation to be true, I need x to be a value of 3. I don't know, perhaps you knew just by thinking 4 to what power equals 64. Perhaps you knew 4 to the 3rd equals 64. You could find your value with using logic as well. But as the problems get a little more complicated, I think you're going to want to use this base skill that I've been trying to emphasize here. Let's do another example, example 2. Log base 6 times 1 over 36, or log base 6 of 1 over 36. I cannot do a rewrite until I do what again? Set it to x. That's an easy way for us to see visually what we're going to do. So I wanted to get that base 6x to 1 over 36. So now, do you know just by looking at this, 6 to what power gives you 1 over 36? If you do, good for you. If not, let's think about rewriting this 36. We can write it as 6 squared, right? And since it's in the denominator, if I want to bring it up, what would it have to be? We bring it up with a negative exponent, right? And so what's the value for x? X equals a negative 2. I have 2 more examples to show you, but they're a little bit trickier. So before I move on, I want to see if you can master this simple skill that I'm trying to get across. So to go ahead and do this, you try, and when you're done, come on back. So press that pause key, take a look at log base 3 of 81. I want you to find the value of this log. Did you rewrite that log such that if this equals x, I can write 3 to the x equals 81, breaking down that base of 3 to the 4th power, I get an answer of x equals 4. Let's take a look at example 3 where I have log base 2 of the square root of 2. All we're going to do is set that against x. We're going to do a rewrite. So rewrites again are very important. 2 to the x equals the square root of 2. So log base 2 becomes the base of the exponent. X equals the square root of 2. My job is to find the value of x. So if I can get the bases to be the same, I'll know what the value of x is. How about if I take this one here and transfer it to an exponential form? Do you remember how to do that? The 2 inside here, the 2 inside the radical has a power of 1. So I have written here 2 to the 1/2 as a power and 2 to the x. And if I just ignore these bases, x equals 1/2. So sometimes you just have to use those old skills that you have. And if you're not familiar, always refer to your notes so you can stay caught up with us. Example 4. Log base 3, 9 to the y power. Let's see what we're going to do here. We're going to set this to x and do a rewrite. 3 to the x equals 9y. Let's carry on like we've been doing with all the other problems. Take that 9, change the base to 3. 3 squared represents the number 9. I still have the 3x, and don't forget that the y is still in the problem. I'm already done. Cross out those 3's. X equals 2y. So you can see the most important part for evaluating expressions without a calculator is to find that base. And yes, set your log to x for your rewrite. We have been not using a calculator to solve our log expressions up till now, but we're going to change that up, and yes, we are going to use our calculator. So go ahead and get that calculator, press the pause key, come on back. If you do have your calculator, we're going to continue on. We have common logs because they are in a base 10, which is the same as our number system, and for that reason, we know that the calculator can handle it. It's programmed to have a base 10 in it. So awesome for us that when we're in a base 10, no rewrites, nothing of that nature. We're just going to go ahead and put it in the calculator. How do you know you're in a log base 10? Well, you won't see it. Sometimes in math, for example, if we had a square root of 25, how did you know to take up for every 2? Because we know it's understood that the index is a 2, right? Well, the same thing happens when it comes to logs. If we don't see the number 10 inside that base there, it's understood to be there. And so, for example 1, this log of 5, we can go straight to our calculator. Since I don't see a base there, it's understood to be 10. And you'll get used to that. When you don't see it, you'll recognize that you can go straight to your calculator because it's easier. And then when anything is easier, we'll remember it, right? So, in our calculator, we're going to simply find the log key, which should be pretty easy for you to find. We've been using it a little bit up until now when we did our application problems. And the next thing we're going to put in there is the 5. And then after that, of course, you're just going to press enter. And you're going to get a decimal on this problem here, and the decimal is going to read 0.689.6989700043. And the book is going to ask you to round to the nearest thousand, and that's the 8. So we're going to look to the 9 and ask ourselves if that's going to go up or stay the same. And the answer is it will go up, and so 0.699 is the answer, and it's an approximation, so we'll use the approximate symbol. That's all you got to do. So go ahead and try that example 2 all by yourself and see what you get. So you're pressing in log, And when you do that, you're going to be prompted to use parentheses, and you're going to, of course, put in a 1, then the division key, and then you're going to put the 5, and don't forget to close the parentheses. So that's our key sequence. I'm just going to separate it out here so you can see how that played out. And then after that, we need one more key, and that is enter. With that, we have an answer of negative 0.6989700043. Did you notice anything here? We've got a log of 5 and a log of 1/5, and they're almost the same with the exception that one is positive and one is negative. You learned something there, didn't you? Approximate answer is going to be negative 0.699. That's all there is to it for common logs. You don't see that base of 10? Go ahead and use your calculator. Common logs have a base of 10. Natural logs have a base of e. And you can see it right here when I say log base e of x. The only thing here is, you'll notice on the other side, there's nothing that even looks remotely like a log. And instead of calling it log base e, for some reason, we've decided to title it ln of x. So log base e of x is written ln of x. And you need to write that. You need to write this down because you're going to see a lot of this. And base e, good news for it, it is also programmed in your calculator. Now to locate that ln key, you might have a separate key called ln, or perhaps, just perhaps, you have a second log key that's the ln. You're going to need to take some time to find it. Example 1, ln of 1.3. You simply are going to go to your calculator, press the ln key, then go ahead and press 1.3, and finally your enter key. And let's see what you come up with. You should have gotten 0.262364, and I don't need to go anymore because I'm rounding to the thousandths. The 3 is going to keep it the same, so approximately 0.262. Now you see this log base e of 6 in example 2. We have to look at what we have written up above there, and instead of writing log e, what are we going to write instead? We are going to express this as ln 6. Now I can go into my calculator and do the math and come up with an answer. Go ahead and give it a try. You got that 1.79175, and that rounds to approximately 1.792. We finally had to round up. All right, so natural logs are base e, and instead of writing log base e, we write ln instead. 3 things to keep in mind as we wrap things up here. Rewrites are a key factor when we're finding values of log expressions, so make sure you know that b to the p equals n. It's very helpful to keep in mind that when evaluating logs, you want to set the expression to x. Use your rewrite and watch how nicely that works out for you. Know the difference between the log and the ln button on your calculator. Log is base 10, ln base e. And that's going to conclude this lesson on logarithmic expressions.